hello everybody. Hi, my voice is a lot better. I hope everybody is doing great today. We have a very, very special guest for today. We have Poisson, or I guess, do you go by Poi then?
Poi or Poisson. Poi boy. Math croissant. Fish.
The
All of the
math
above.
croissant. Well, let me know if you guys can hear the math croissant.
Hello,
Yeah.
hello. Test.
Testing.
Testing.
Yes, everyone is super excited. I love Poi's model. I do too. It is very colorful indeed.
Thank you.
I hear both of you audio is good. Okay, great. Wait, that's great.
Sweet.
It's been a week since my last stream. And I just quickly wanted to say thank you guys. So sound is decent. I can reduce the music too. I just wanted to thank you guys so much for your patience. I'm still sounding a little bit sick. I still cough like every once in a while, but after after last week where my voice was basically dead, my voice actually got worse and now it is better. That shocked expression is definitely my it was so bad. I was like bedridden. I was like sleeping, trying to cure myself, like taking Sudafed, Mucinex, all of these things to like clear my sinuses. On top of that, I got some great tips from you guys about how to recover my voice, so thank you so much for that. We even had like a registered nurse like comment on my being like you should put your face in a humidifier, and that was actually very helpful. Yeah, no, it was crazy. I was like, there's no way this is gonna work. And then I like put my face on top of the humidifier for like 15 minutes, and like my voice went from being unable to like say anything to being able to say words for the first time. So that was great.
That's awesome.
Yeah, so yeah, no, I've been definitely through it this past week. I'm still going to take some time to recover for the next few days because if I talk too much, my voice dies again. But I'm hoping to get back into schedule. And that being said, enough yapping from me. I wanted to let Hassan introduce himself.
Hey, my name is Poisson Invariance. Technically it's Poisson because French, but I say Poisson because American. I am an applied math VTuber. I love math, as you can probably see. I also go by the fish or the math croissant, poi boy. Any of those work. So yeah, and I am very excited and have been looking forward to this collab for a while.
No, I'm so glad we made this happen because I remember we were talking about this for a while, and what's crazy is that this is happening right after, like, literally the next stream after my collab with Aleph.
Right.
Which is, like, wild.
It's the sphere of mathematicians, which you grab one, then you're stuck with all of them. It's just how it goes.
I just feel like you can never have too many mathematicians. I'm, like, collecting them all, like Pokemon.
we can't fight, but we will talk someone's ear off. The axiom states.
Actually.
Exactly. Yeah.
That is true.
We're
actually, I have a quick question for you. Do you like croissants?
I do like croissants. I'm a big baked goods fan. I think that's probably like my dessert of choice is stuff from the bakery.
That is very good. Well, that is very base take.
It's actually a very baked take. Thank you very much.
Wait, doesn't baked mean something different?
Well.
I like found out that like baked may mean another thing like very, very recently.
Wait, does it?
I think baked means like when you're like on weed.
Oh, that baked, yeah.
Wait, that being said, I did not know that this was a thing until very recently. Nep has ruined me. That is true.
Of course, the plant biologist is like, so I got a cool plant for you to hear about.
Well, for this very say-so stream, you're right. We need to refer to just baked goods only.
Well, I'm curious. What's your go-to dessert type?
Oh, I love ice cream. I love chocolate ice cream. I think that is my go-to. I think like at one point I was averaging like one chocolate ice cream per week. It was a little bit crazy.
See, I've never been able to do chocolate. That's always just nope.
Really?
Big nope
What?
for me.
No, for me, I like don't in chocolate. Well, I'm
Oh.
actually curious from the Orbeez. Do you guys have a favorite dessert?
Mhm.
Or wait, Chloe, what are your do you have your fandom name?
Yeah, they're the variables.
The variables? Wait, that's so cute. That's so cute.
I wonder if I have a little gif of them or something. Cause do you have a mascot for them for the Orbeez?
We've had a few floating around. I really love Shiba Inus. So there was one that was like a Shiba Inu wearing a astronaut outfit. That was one common one. There was somebody made like one with a spear. Hello Syzygy. Welcome to the yeah. So there's been a lot of variations. Oh my god! Thank you Syzygy for following. Chocolate cake. Strawberry shortcake. Wait, what are your thoughts on cheesecake? Because I actually love cheesecake too.
I am also a big cheesecake. I'm all in on cheesecake.
Cheesecake? Okay.
Cheesecake.
Yeah.
Okay. We can agree on some things. Okay.
Yeah. So if we ever do a cooking stream, cheesecake is the way to go, it seems.
Yeah, because everyone knows the only way to do a cooking stream is copious amounts of sugar. You know, nobody likes protein.
Wait, recently, like, well, as I've been recovering from my illness, right, a lot of my friends have gotten me, like, different treats to, like, help me feel better. And so, oddly enough, my diet has been, like, chocolate pretzels and, like, what else? Like, I had banana bread the other day, like, and I've just been, like, eating all these snacks, and I feel better when I'm eating these snacks. But then, at the end of the day, I'm thinking, like, oh, am I really getting better after eating all of this sugar?
I feel like if you have a hurt throat, is salty foods gonna help with that? Like salty, like pretzels are salty.
I think it's making it worse. Maybe it's making it worse. Oh my god, you're so right.
Ibara, Syzygy. Oh, Syzygy also subbed to me. Thank you.
Yes, and hello Stella, good seeing you too.
Someone in my chat wants me to ask you about Amogus. What are your takes on Amogus? Oh no.
Love Amogus. Actually, if you type !Amogus on YouTube, I think like an Among Us pops up.
Oh my god.
Was it? Yeah. I love Among Us, but I'm actually really bad at the game. What's really funny is that like I can do this thing. I guess my hand tracking isn't good enough. But if you like put two of your fingers together and then you put your other hand like a crescent, you can make an Among Us with your hands. And I used to take photos. When people are like, "Hey, do a silly photo," like I would make an Among Us with my hands.
My god.
And like teach people how to do this for the silly photo. It's so crazy.
It's funny that you say you're bad at Among Us because I don't like lying to people.
I'm just bad at lying. Like that's just what it is.
So you're willing to, you'll just get caught.
Yeah, no, I just feel like I'm really good at being crewmate though, because I get my tasks done so freaking fast. Like people have been shocked. They're like, "Oh my god, Z is so productive in Among Us."
I think that makes you more suspicious though. It's like, are you sure you finished all your tasks? It's like, yes, I did.
I've gotten like suspicion from that before. Like people were like, "Oh my god, like are you faking your tasks?" So
sometimes you're just that good, okay? Don't hate the game.
Lock in.
Right? I feel like that's very STEM major coded of we're gonna be as efficient as possible.
Yep, it's a STEM major in me. That being said, we should start going through our questions.
Oh, you're right. It's like the whole point of this.
The whole point of the stream. OMG.
Also,
yeah. So, did you just want to go from top to bottom, and then we'll see? See how far we get.
Yeah, I figure we can do that. Oh, people are trying to do the Amogus in my chat. No, in Z's chat.
Yeah.
The link is in the description. Oh my god, they're using the LaTeX typing to write Among Us with like the text.
Oh my god. Wait, that's crazy. Wait, let me see what your chat is doing.
Oh my god.
Oh my god, that is crazy. Math BB Among Us. This is golden.
Do you, yeah, do you have the LaTeX thing for your chat?
Oh, I need to set this up. I need to set this up.
I know.
Is it a YouTube bot?
No, so ask Aleph Mew about it. He helped me set it up. He got it from someone in his chat. It doesn't entirely work yet in my chat. I still need to fix it. I have a whiteboard above my desk that I wrote down notes of fix LaTeX chat box, but I'll get to it.
Yeah, I'll definitely check it out for sure. Wait, that's super cool.
I know. I want to be able to.
I wrote my thesis in LibreOffice. That is the most cursed thing I've read. That's like writing your thesis in like Word. That's crazy.
Oh my god! When I was doing, I know this is art. So when I was doing a research paper, with like an actual lab, so instead of just making a shared Google Doc, and the thing is, the lab was we all used Google, like Gmail and Google Drive and Google Slides and stuff. For some reason, the people in my lab, these like experienced researchers, said, no, we're gonna make a Word document and then email it around to us.
Oh my god.
And so it was just, do you have the latest version of the Word document? No, ask, person Y. And I was like, do you have the latest version? Yes, let me send it to you. Download it, then I have to send it back. Right. Oh my god.
Wait, what's crazy is like I have a friend who is in chemical engineering, and she was like saying that her group uses Microsoft Word, but that was like there is like a collaborative feature, so I guess it wasn't as bad as yours. That's crazy.
I'm pretty sure there's in the same way that like Google Docs can do it, you can like hop in if you both have like Outlook or something.
It's so funny.
I think
wow.
The annoying part is that I wrote the first, because I was the leading author, so I wrote this first draft in Overleaf, sent them the link, and one of them goes, I don't really know LaTeX, so I'm just gonna switch it to Word.
No, wait, this is so painful.
It was so bad.
I'm so sorry that you had to go through that. That is crazy. I've never heard of anything like that.
And then at the end of it, when we tried to add, because again, I had put all my like figures and stuff initially in LaTeX, and I was like, okay, here are the figures, and then they tried to put the figures in Word, and they were just these blurry messes, and then they tried to send it in, and none of it was formatted correctly because it was all done in a Word document.
What's really bad about a Word document is like you move like an image that's in like wrap mode like 3 millimeters to the right, and then just like warps the entire document. It's so bad.
I see you move something on page 3, so page 6 through 9 is now just gone.
Yeah, it's so bad. Wait, that's so funny though.
It was painful. My worst experience.
Well, speaking of, I guess that might be an interesting segue. Given the pains that you've suffered in your research, we can go through our first question. How did you get interested in your major or field? A very smooth segue.
Oh yeah. I'm not. I hate it. No. Well, so fun fact, actually, initially, I wanted to be an astrophysicist.
What? No way.
It starts as most stories do with fighting a turkey. Oh wait, that's the wrong story. It starts as most stories do with watching a scientist on TV with Neil deGrasse Tyson's Cosmos.
Wait, that was literally like, that was such a life-changing moment for me too.
I love that. I love Neil deGrasse Tyson. He's got just like, I don't know how to describe it. The perfect scientist energy, where he's like doesn't put up with anyone's BS, but he's also just so fun.
He just has so much aura. Like, he's just like, when I think of like what a good scientific communicator is, he's like the first person I think of. Him and then Bill Nye.
That's what I was about to say, where they're both like charismatic, but also, again, no BS and incredibly smart. Give me 1 second, sorry.
Neil deGrasse Tyson is so good that you evaporated.
I'm back. All right. But yeah, so I had originally wanted to be an astrophysicist. I watched Cosmos, and it was so much fun. I remember I would watch it like every week with my dad, because I think it was weekly, and it was on like PBS or something. So much fun. And so that was the thing, I want to be an astrophysicist all the way through high school. But as I was going through high school, I was like, I'm never actively searching out more about space. I'm never going that extra mile to be like, oh, I want to learn more about the stars. I want to learn more about the constellations. I want to learn about planets and stuff. But I was doing that with math, which was something I had always excelled at, and I had been crazy enjoying. Stella, thank you for the sub. Sorry. But I had been excelling in that, and then I was just like, holy heck, this is what I love. This is what I want to do. And so just I got into I was taking college courses while in high school, and I was like, I'm not even gonna bother with any astronomy courses because I know I want to already beeline it for the math degree. Yeah.
Wait, this is so interesting because I feel like there have been so many stories. I mean, maybe I've heard so many stories of like how people enter the field, and people really enter it at different points. But I feel like you started out pretty early then, if you kind of knew you wanted to do math that early on.
Yeah, it was one of those things where I really enjoyed learning as a kid. I enjoyed math as a kid. I remember when I was like 6 years old, my grandparents for Christmas got me a just like math workbook, and I just did it all. I was just like sitting in my room like, ha ha, just like having a wonderful time doing math. Some kids got Transformers, some kids got, DS games. I got a math book, and I had the time of my life.
That's crazy. At age 6, that's wild.
Yeah. It wasn't complicated. It wasn't like I was doing calculus, but still, it was just like...
Still, I mean, like, people find enjoyment in, like, so many different things, but, like, at age 6, like, I don't know, like, I don't even think I was thinking about science at that age.
Yeah, I did. Well, so then when did you start? When did you have your first spark?
What's really interesting is that I feel like I got started around the same time as you, but maybe not as early as 6 years old. I remember when I was little, I did love reading. I had this really... I think the Orbeez have heard this story. When I was little, I'd do this thing where I'd, like, go through my entire bookshelf. Like, I'd take off every book off the shelf and then read it again or something, like, every single day. It was, like, a weird habit of mine. So I loved reading.
That's awesome.
Yeah, and so, like, I guess my interest in astrophysics began in middle school. I had this really amazing science teacher. She, like, absolutely changed my life. And I remember she was telling me about how, like, Pluto was being, like, demoted as a planet. I was thinking, like, that is just such a weird concept to me. Like, what could it be? Like, and I read so many books on it. I read so many books about how, like, Pluto's being demoted and all these different details. And I just loved it. And from there, I went to starting to think about, like, cosmology and, like, larger astrophysics. I think I also really, like, locked in on my interests in high school. I was also taking, like, college courses in astrophysics in high school, funnily enough. Like, I guess like you, but not in math, I guess. And so, like, and then since then, I've been really locked in on this. But I think that being said, one thing that I really want to emphasize to the Orbeez in the chat is that, like, there have been so many different stories of people that I've heard in astrophysics research who have gotten to that point. Some people didn't know what they wanted to do until a year before they applied to grad school. Some people didn't know what they wanted to do until they got to college. There was somebody that I met recently who was, like, 50 years old and going back to school. Like, I just think it's never too late to get started, and it can be really... And I will talk about imposter syndrome later, but one of the things that I really want to emphasize is that, yes, like, we may have taken college courses in high school, but everyone's journey is different, and just because you start earlier or later, I mean, at the end of the day, if you're passionate about something, that's something to be excited about.
Right. Because, like, at the end of the day, if you're having fun learning, and also it doesn't matter if you start really anything, like it isn't even necessarily going to college, just really anything. You can start it at whatever point in your life you want. Like, the only thing that holds you back is you from achieving your dreams. Inspirational speeches.
Yeah, I think there's also people saying stuff about, like, oh, your brain is, like, less flexible when you're older, and it's harder to learn languages and stuff like that. But I met somebody who was a survivor of Hiroshima, like the Hiroshima disaster, and she learned English, I think when she was, like, 60 or 70 years old, like basically, like, the later stages of her life. She learned English completely fluently so that she could tell her story as a survivor of Hiroshima. And
that's insane.
That was like, I mean, that I think is such a beautiful example of how there's never a point where it's too late to learn.
That makes my story about having a quadrilingual friend seem way less impressive.
Wait, a quadrilingual, like 40 languages?
4, not 40. Quad.
I actually know someone who knows 12 languages, so.
Where do you find the time?
Well, I think this person was like, he was like the son of like a diplomat or something, or like grew up like having to travel a lot.
That's,
yeah.
I mean, I guess that's one way to do it, but still, that's. I don't know how you do it. I don't know how you could possibly keep that. Like, how do you learn that? How do you learn
crazy
that
because
anything else?
I struggle to pronounce things in English sometimes, and that's that's language 1, bro.
I know. I'm ESL, and the S doesn't stand for second; it stands for starting. But I'm still ESL.
Wait, I just saw you typed a question on our doc. So do you feel?
This because
I'm curious to hear what your thoughts are on this too.
Okay, so the scientific community has deemed it as decided, and so I abide by this. I do not believe that Pluto is a planet.
See, I also agree with you. I think that Pluto is not a planet, but I actually came across, somebody sent me an article the other day about how like the director of NASA is trying to put back into the conversation like Pluto being a planet. I think if you wait, let me pull this up on the side.
Yeah.
Pluto is a planet, NASA director. I think it was Jared Isaacman publicly advocated Pluto's status as a planet.
Interesting.
On April 28th, 2026. Yeah, this was like 2 days ago.
Can I ask why?
I think it's just like the cultural relevance. I don't understand why he said that. I don't understand why he said that. It seems like a lot of the Orbeez in the chat want Pluto to be a planet.
The number of people I've talked to where they will die on this hill where they tell me, and multiple people have told me this, and this is the crazy part. I'm emotionally attached to the idea of Pluto being a planet. And I don't get what that means.
Well, I think it's a charming planet, you know, and I think like you know, a charming dwarf planet, sorry. It's like, you know, like, oh, Pluto's the one, or like, it, you know, it has a cute name and whatever. But I think there's a statistic that if Pluto is a planet, then we'll have like dozens of additional planets in our solar system.
Right, that's part of it, where it's like, we're not going to be able to teach people easily the solar system in school anymore if that becomes true.
Yeah, I don't know how we'll be able to think of acronyms anymore.
Wait.
Like, you know, like my mother pizza. I don't know. Like, I don't know how you learn the planets. Like Mercury, Venus.
I have no idea. Like, you said acronyms and then said my mother and then pizza, and I have no idea where you were going with that.
Solar system, planets, acronym? Like, oh, mnemonics. My very educated mother just served us nachos. And every letter is like... I just said my... It's so funny because I just said my mother, like, thinking that you'd, like, understand the context.
My mother, you know, the nachos? She went to college. You know?
we teach the first 20 chemical elements in grade 9 just fine. That is a fair point, but I just think, I don't know. I think, the scientific community made a decision and it's it. That's it. I don't know.
I'm fine. I'm fine with them because clearly they did it once. I'm fine with them making addendums to the decisions based off new information and new classifications. But I don't like the idea of Pluto getting shoehorned back in because, oh, people really like it.
Yeah. I think, it could... I just don't think it should be re-added as a planet. But, I mean, people already know about Pluto.
Right.
I think people learn about Pluto more than they learn about the other dwarf planets. So it's not like people have forgotten about Pluto.
No, I mean, maybe that's the emotional attachment that people have to it. We won't never forget Pluto, I guess.
Yeah, no, exactly. Yeah.
Crazy.
All right, do you want to go to the next question?
Yeah.
I'm actually curious about what you think about this, because I never considered, actually, I guess I should have said this, I never considered, a career in math.
Mm-hmm.
So I'm interested to hear what your answer to this question is. And the question is, what was your first challenging course in your field?
So this one comes from an interesting place. So I don't know about you, but, and I feel like I've made it clear with this anecdote so far, I was considered a quote-unquote, gifted kid. You're excelling, you had high expectations, whatnot. A lot of, oh, you're so smart, you're gonna do great things. And so I never actually learned how to study. I had no idea how to study, how to prepare for a test, how to prepare for anything, because my entirety of classes had just been, well, I just know it, that's obvious. And I don't mean to, no, that is not what anybody should be doing. Nobody should feel that way. No one should feel like they should know everything. It's just certain people I can't draw really, but other people have been drawing since they were 3 years old and are master artists by the time they're 12. So people adapt in different ways. But so it was when I got to Calculus 2 and I was learning about integrals. And I remember doing this homework, and I had just, through Calc 1, I had just kind of breezed through it, and I'm sitting there, and it was talking about the shell and the disk method, and I think, what the heck does any of this mean? What have I actually learned? What have I actually synthesized from all of these functions and graphs and whatnot? And I realized I had no idea. I didn't know. I had passed Calc 1 without understanding what a derivative meant.
Oh my god.
Right? So I start trying to what does it mean, this shell in the disk? Why is it calling this? Because there had been no visualization for me. And it was the first place where I started to just hit this brick wall. And I was like, okay, I need to understand what I'm actually doing.
Wait, do you mean Calc 2 as in I guess I'm thinking about the AP system, AP Calculus BC, for instance, or...
let's see. For me, Calculus 2, so I was still in high school in the time, but like I said, taking college classes. Yeah. Calculus 2, in my case, was stuff covering integrals, Riemann sums,
okay.
That kind of stuff. It highly integration focused. And yeah, it was that point where I realized, I had no real understanding of it. So an applied mathematician who initially didn't know anything about math, but was good at it, so kept going at it. And so that's what I felt. I was like, okay, I need to make a change. How about you?
Well, I did want to say that in chat, there's a lot of people, Akari, Galileo, Kingwin, who have all been sharing this same experience especially about what you're saying about understanding the applications of math.
Mm-hmm. And I think that's actually why I ended up, instead of becoming a pure mathematician, became an applied mathematician, was because I had to take that step back and be like, okay, what does this mean? And then I started looking at examples, and I started applying it in my own head. And then I was like, oh, this is fun.
Yeah, wait, that's super interesting. I was gonna say, like, I feel like what you mentioned about, like, not being able to learn the applications is something that I've felt in physics as well.
Do tell.
I think somebody was saying, King was saying, like, I wish they explained why I needed the Fourier transform before teaching it. Like, for instance, like, that is also very important for physics.
Uh-huh.
And I guess it probably felt the same in math as well.
Yeah, pretty much. Sorry.
Oh, no, you're good, you're good.
Tried
I think, like, for me, I think Gaussian said that the challenging course was General Physics 2 Gauss's Law. I think ENM was really tough for me for the first time. But I think the one that, like, really killed me was quantum. There was just something it was very math-based, but it goes against every single intuition that you might have gotten. Like, it goes against, like, your basic understanding of mechanics. And it took me so long to build up an intuition for how things worked. And let alone, like, being able to apply this intuition to different problems. But I think also one of the things I wanted to comment on, which I think you may have felt going from high school to college courses, is that in general, going from high school to college is very challenging indeed. I think one of the things in high school is, like, a lot of the stuff that you learn, whether it's, I'm not sure as much about the AP curriculum, but it's very, like, memorization based, or just plug and chug, these are the equations, like, here you go. But when you get to college, you're thinking about, like, how do you actually derive the equations? Like, what do these actually mean? And sometimes that transition can be really tough. And I really think that the teachers that do the best at teaching introductory level physics courses are the ones that are able to use, like, an active learning style where students are actually deriving the equations themselves and understanding where it's coming from instead of just plugging and chugging. But of course, that transition from high school to college can be, like, a really big gap.
Oh, yeah.
It might be the same physics, but you're applying it in such a different way.
And that's actually, funny enough, why I never really took much after. I never took any mechanical engineering or anything. I never took much after, like, kind of like a basics physics 1 and 2 kind of thing, because one of the things was that I still have trouble with setting up models in physics, like basic models. I don't know how to do it. I don't have that intuition. When it comes to physics, when it comes to those sorts of things. I could draw one of those, like, fall down a hill and then it does a loop. Now label the forces, and I wouldn't be able to. I'd be like, gravity. That one I know. I experienced that one quite a bit.
I do have to say, though, like, I think for me, like, math also can be, like, really difficult to visualize, especially when it gets more abstract.
Anything. So, like, 3D is already hard for a lot of people. I knew someone who, when they were learning 3D vectors, they could not visualize 3D at all. So the professor would, in their office hours, have them stand in the corner and say, okay, now this corner is your 3D vertex and whatnot. Stay there until you understand how this problem works.
Wait, that's crazy. What? Wait, I thought this was gonna go in another direction. I thought you were gonna say that the professor, like, pretended to be, like, a 3D vector or something.
And so this person ended up standing in the corner of the professor's office just trying to visualize this for, like, 20 minutes about how this 3D field could work, how this plane could work in 3D. It was great.
That is a crazy teaching example. I don't know if that is the best way to teach.
Absolutely not.
Yeah. Someone asked, did they have aphantasia? Yeah, so isn't that the thing where you can't really visualize 3D or shapes in your mind very well?
Oh, yeah, I think you're right. And I think that's what it is, because I remember talking with them, we were working in a tutoring center together. And funny enough, we were talking about the shell and the disc method, and the only way they could ever do it is they had to pick up a water bottle and they had to spin it around on the desk, and they said, okay, this is what's happening. This is exactly what's happening. Now I can see it.
That might actually be that aphantasia thing. I've never encountered anyone with that before, actually, but it's interesting to hear that. I feel like also, like, being able to teach physics or math with a student that has that, like, I don't even know where I would even begin. Like, I guess you'd have to just speak with the student and see, like, what their experiences are.
Right, because, like, calculus is all pictures, so I hope you got good visualization skills. This is not a great start for some people like that.
Oh, huh.
Ooh, okay, someone in my chat has aphantasia, apparently.
Yeah.
Crazy.
Windfall Conjecture says so too, and apparently my one of the Emeritus V-Tier members, Sai, also told us that she has aphantasia, which is interesting. I actually didn't know that. I'll have to ask her about that. Maybe she has some experiences.
Yeah. Have her draw you a picture of how it works.
Because good luck visualizing a 1 billion dimensional vector space. Wait, it's crazy because in like machine learning research and stuff, like you do a lot of stuff in like, many dimensional parameter space. But for that, like, we can't visualize things that are like beyond 3D or even beyond 4D. And so, like, in those instances, you can't really visualize it at all.
I mean, a lot of that stuff, like in my experience, is you end up having to use different models to compress it down to or truncate it down to 2 or 3D. And it's like, and then we cluster it, and you're like, this is the best bet we got on how visualized these are. I hope the PCA model reduced this well. Like, it's kind of a shot in the dark in some cases, which is why I'm not a huge fan, but I'll save that for another day.
Yeah. Somebody says there's a simple aphantasia test, and I looked this up, and it says you can close your eyes and try to visualize a red star or an apple. If you cannot form a mental image, you may have aphantasia, or you might have like a vague or dim image. Well, I know for a fact that I don't have a... Are you thinking about a red star?
Thinking about the apple. I've seen more apples than I have stars up close, so that one's easier.
Well, I know for a fact that I don't have aphantasia because actually I think I'm the opposite. In fact, I feel like I'm a very visual learner.
Ooh.
Like, for me, I need a visual is like the way I learn best.
So, does that mean that you're fine with a 3 billion parameter vector space?
No, of course not, But I think, like, when it comes to, like, explaining concepts or, like, thinking about vectors, like, I can definitely visualize them in my head. And actually, if anything, drawing them out on paper helps me understand the problem better.
Alright, I'm gonna have to recruit you at some point to teach me how to make basic physics models.
I got you. Most of them are just really crude drawings in my horrible handwriting.
The visualization... perfect. The penmanship.
Yeah, no, I don't know what your handwriting looks like, but mine can sometimes go off the rails for sure.
Actually, fun fact, you do know what my handwriting looks like, because all of these equations are my handwriting on the shirt.
Wait, your handwriting is so clean then.
I tried. I tried in this instance.
I mean, some of the Orbeez, if you've watched I say recent, but like my old videos on my channel, I use my handwriting there.
Yeah, I've seen that with like
good enough.
Exactly, it passes. No, I'm just kidding.
Yeah, it passes. Yeah, I mean, I'm not like a calligrapher, but yeah.
That's a different field. Wait. Hold the phone. You did the whole cuneiform stream. So instead of handwriting, but you have good ruler writing, I guess?
Oh, well, yeah, well, I guess, well, the cuneiform stream was my cuneiform handwriting, I guess. I don't know, I don't think that translates well to actual handwriting, as I was just making wedges with a ruler, but maybe.
I think you're selling yourself short. I think if you put down excellent cuneiform handwriting on a resume, they would love it. They wouldn't.
Wait, I've been like calling my friends in like my research group about like about my cuneiform. They were like, "Hey, what were you up to like a few weeks ago?" I was like, "Oh, like I learned how to write cuneiform."
It's a really funny thing to just like drop on people.
Yeah, no, I just love like random lore drops. So,
what were you up to? Oh, just ancient Mesopotamian linguist.
learning how to write the king's name in cuneiform.
Hammurabi had some crazy stuff to say. Yeah. You
That's
should look
true.
it up sometime.
So did Ian Nasir with his little all the complaints.
Oh, right. I saw that.
Hopper. Yeah.
Listen, that's some commitment to being disgruntled.
Mm-hmm.
I admire
What's crazy is that there wasn't just one tablet, but they found like multiple tablets all around this dude's house.
This is the equivalent of somebody like tweeting a million essays to no one, like no followers, but I'm gonna write angrily for everyone who happens to stumble upon my Twitter page to see.
Yep.
Again, admirable.
It was hilarious. Yep.
I don't know if so did you actually answer did you answer what your first like challenging course was for you in your field?
Oh, for me it was quantum.
Right, that's what it was.
Yeah. Well, I guess along those lines, do we want to go to the next question?
Mm-hmm.
What was your favorite course?
Ooh, so I have a few different answers.
Ooh, okay, that's good.
Yeah, so my favorite course in terms of pure subject matter was probably numerical analysis. Surprise, applied mathematician.
Okay.
It was a ton of fun. The data visualization I loved, and again, that all translated great into stuff like machine learning. It was the like I still don't know how to say if it's spline function or spleen function. I don't know. I like saying spleen because spleens, but
Wait, spleen? I've never heard that. That's crazy.
But it's this whole numerical property and going in depth on stuff like Taylor series in really cool ways. I really enjoyed that, and it was the first class that I ever had where I was, even though I was an undergrad taking it, I was with grad students, and so I made these like grad student friends, and so that's a very memorable course for me, and the subject matter I loved. The other one, though, and I think is my favorite course just because of the experience, is geometric analysis. Because
what is that?
So it ends up taking basically the class was a combination of real analysis and geometric analysis, where it ends up taking basically everything that we know about math and recontextualizing it in the same way that algebra gets recontextualized by abstract algebra. Basically, it redefines how we look at derivatives, it redefines how we look at sets, it redefines how we look at functions, it redefines how we look at continuity. In tons of different ways, and a big part of that was this discussion aspect where we were this small class of 15 people maybe sitting in a room that was just a circle, and we would just sit and we would just talk for an hour straight about math it was like 3 days a week. We would just meet and just talk about math for an hour, and that was so enlightening because we had this guy who had like worked in like nuclear physics research and whatnot as our professor.
Wow.
And we had physicists in the course. We had mathematicians like myself. We had pure mathematicians. We had mechanical engineers. We had this like diverse array of people, and we would just sit and shoot the breeze about math for an hour several times a week. And then afterwards, we would all go hang out in this little living room outside of the professor's office with a chalkboard and just keep the conversation going.
Wait, I love that though. I feel like the best classes are the ones where you like really build community.
Absolutely. It was, and so that by far is my 2 analyses courses are by far my favorite. The favorite ones I've ever taken, both for material and just, the community and the experience, which is something that people don't, I think, focus enough on in college. Is it's not just about the piece of paper. It really is about those connections, both between students and professors. That's like so powerful.
Yeah, I also agree with that. Like, I feel like, you really meet people with similar interests in these classes, and you kind of find your community through that while you're, like, working through the homeworks or the problem sets.
For sure. What about you? What's your favorite subject or course?
Ooh, okay, so I guess, since we've been talking about, like, class community, and I also saw Eggy said something about a creative writing course that they did.
Ooh.
I think okay, I'll answer one that's like more physical, and then I'll answer one that's like more fun. The more fun one, was I was in this class that was like storytelling.
Ooh.
Where we would, I kid you not, like tell stories about like from our lives.
Oh.
It was just so much fun. Like it was just like a class where we got to yap. Like.
I see how the VTubing started.
Wait, this was like long before, yeah. But I mean, it was a lot of fun. And also the big part was like, we really got together as a community because we were sharing these stories from all different parts of our lives. And also like some of these stories that some people shared were especially fun. I just felt like we really got to know each other. And there was some friends that I've gotten from this class and I'm like still in touch with, and we still are like, hey, remember that like random storytelling course that we took where we like, I don't know, like where we were just like yapping about gossip and that kind of stuff. Like it was just so silly. And it was so fun. And then we had like a final showcase where everybody kind of like focused on one main story, and it was just a really great experience. A lot of people were there because they wanted experience with public speaking. I was kind of there just because I didn't really know what else to take, and I just found these people from like all different majors. Like I was the only one in that room doing astrophysics. There were people from like all these different like degree paths or even like stages of careers, like in this classroom, like all sharing their stories. So that was probably my favorite fun course. My favorite physics course is oddly not an astrophysics course, but I really liked partial equations. This is a pretty hot take, but I just remember during the course it was really hard. Like as in like I turned in my problem set and I remember one of the answers I got was 2 pages long. Like the answer, like the box answer was 2 pages long. Like the equation was that long. But I think at the end of the day, I just found it really exciting to bring like a physics application to math.
Oh yeah.
And also it was kind of satisfying, like turning in my problem set that was like, what, like 70, 80 pages long and being like, ah yes, I have completed this. This is my masterpiece. And like, I have done this.
Now I'm gonna have to do it again next week.
Wait, it was definitely hard. Yeah, every week was definitely a challenge, but I think like in retrospect, I had a lot of fun. And also another part of it was I made a lot of friends through that class because we were all suffering together, so yeah. Oh
no, the speed run in my chat says PDFs are their, or PDEs are their nightmare.
Wait, so, Convergence series in my chat says that PDEs is a goated subject, but maybe their username is biased, you know?
I mean, that's fair. That's fair. I think it's one of those things where I can totally see you loving it or hating it, because if you make one mistake, you're screwed. That whole question is down the drain.
Yeah.
But there is something, like you said, so satisfying about getting to the end of my magnum opus of math equation to turn this in. It hits different.
Yeah, no, for sure, for sure.
Actually, funny enough, I'm gonna segue to the next question. because mine's related. My least favorite course or subject was not actually because of the content and all. I love learning. Most classes I can get into. I took a psychology course. I looked an intro to psych course. Loved it. I took one on like the social disparity of like race in America. Loved it. My least favorite course was a differential equations course. And for the sole reason of the professor. In the middle of one of his lectures, halfway through the year, he was impressive. He would like derive everything from memory and whatnot. So like he would be like, okay, the heat equation, this is how we do this. Okay, this is probably how it goes. Then derive it on the spot. In the middle of one of these derivations, he sets down his pen, he leans back in his chair, and he goes, you know, I don't really care for math. To a room full of mathematicians and engineers and physicists. I'm sorry, what?
You just like had like a crisis, just like a midlife crisis.
And it's crazy because he's like, I like to draw pictures, I like to drive my car, I like cooking, but I don't really care for math. You know, I got into math because a bunch of it's been solved already, so it was easy. I'm like, huh?
No way. That's a diabolical statement. That's crazy.
And so I ended up checking his like rate by professor after the fact and talking some other people, and I was like, oh, he is people were not a fan of him for stuff like that. And then I learned from the professor of the geometric analysis class. He ended up telling myself and one of my friends kind of like in private, because we were like, you know, you like bond with professors, and so they're willing to spill a bit of the tea about other faculty. He said, yeah, they're currently trying, because that guy's tenured, they're currently trying to find a way to give him the class where he's going to do the least amount of damage. And I'm like, oh no. My God, no. It's so painful. And and what sucks is that analysis professor, he was teaching back-to-back analysis courses, one in the fall and then one in the winter. So it was like analysis 1 to analysis 2, and he had always taught those two back-to-back. They ended up giving analysis 2 to this professor who didn't care about math because they felt that was where he was going to do the least amount of damage. And I just felt so bad because this analysis professor loved analysis. He loved teaching these back-to-back courses. And now he loses one to this dude who straight up doesn't care.
Oh,
so sad.
I mean, that's crazy. I also did want to say that, like, I think, I'm sure this is present in math as well, but in physics, it's true that I wouldn't say a lot, there are some professors out there who struggle to balance like the priorities from their research group and from their courses. And I think honestly, like, that is definitely a very hard battle to fight.
Oh yeah.
I think there are like, I guess like one of the courses that I took that I wasn't a huge fan of was where it did feel like the professor was not as accessible, like whether it was for office hours or for like asking questions. But from like after we took that course and after students, like all of us, we like gave our feedback, what really this actually has a better story, a better ending than I think what happened to you, which was that the professor actually got sent to this like training program where they were teaching how to be like a more accessible professor, especially for introductory level physics courses. And afterwards, like, I was talking with some students who were taking it like a few years after me, and they were like, oh yeah, no, like this guy was like a pretty decent professor.
Wow.
And so I think, like, you know, like I think there, like, if you get stuck in this like in this this struggle of like that research versus like teaching courses, I think there are definitely, like, it's not like an end-all be-all, that, and I feel like there's actually been like good cases in which I've heard that like getting sufficient training for like teaching these courses is important.
That's honestly such a like relief to hear, especially with how like sometimes ego driven and political certain institutions can be. sometimes it can be really hard for a professor, especially like a tenured professor, to be told and to hear, listen, buddy, you're maybe not giving the students what they need.
Yeah, I think like the best professors, even if they're not the best teachers, the best professors are the ones that are willing to take that feedback and not, like be able to. The professors are able to incorporate that feedback into their teaching.
Right.
Being open to constructive criticism.
They're open to learning the same way the students should be.
Yeah, no, I mean, I guess that also comes to show a common theme of today's stream is basically, like, it's never too late to learn.
Absolutely.
Even if it is learning how to teach. But I think, like, that's the kind of thing they don't teach you in school, right? Like,
right.
When you're doing your problem sets, or when you're doing your, like math or physics or research, like, those are very different skills from, like, having to teach an introductory level physics course to students who may have, had less exposure to physics in high school.
Oh yeah. It's one of the reasons why I think it's so beneficial to, during your time in college, being a TA, being a tutor, or even in graduate courses, being able to teach is such a powerful experience. Because you're not at the end of your career, or like this isn't like your career, you're still like getting started, and so you have this like leeway to have these experiences, and you're closer to the students. You're a student as well, so you're probably going to be more open to accepting that kind of feedback. You guys are going to be on a very similar level, and so if you're, say, tutoring someone and they go, I'm going to be honest, I have no idea what that means, you're going to be like, okay, that's great to know, so I can, that means I can't communicate it as well as I should, and so you can go back and try and revise that communication. And
yeah.
It helps build up the relationships with the students as well. Like, if you're willing to take criticisms, they're gonna like you more.
Yeah, actually, this is a perfect segue into one of the other questions that we had, which was how easy was the connections with your professors? Or I guess like I've gotten a few questions in the past, like prior to this stream, about forming connections with professors outside of the classroom. Like, how do you navigate that? Do you want to answer first?
Oh, sure. So, as I had said before, one of my favorite experiences was with that small class where it was this small group, some from the same cohort, but from a lot of different places. And it helped that the professor was very open to stop by my office hours. He was very vocal about that. And so he was very, very excited to have people come to him and talk with him and work with him on stuff that was completely irrelevant to the class, but was just about math or subject fields. And then he would actually direct us to other professors who would be able to help us more, and he was very humble about it. He was like, oh, if you like working with me and you're in physics, go talk to this person. He is a genius. And that I think was really powerful. But sometimes professors don't do that. Not everyone is so open about that, or so like, hey, come talk to me. So being professionally courteous and reaching out to people to say, hey, I know you're busy or something, would you be willing to take half an hour to have a meeting with me about a specific thing? Being specific about what you want to have a meeting about. Being like, hey, I noticed your research in X, or I noticed your research in Y. Knowing what they're actually working on, and then saying, hey, could I steal a moment of your time to talk about this specific thing? Because they are busy people, and they will take that time generally out of their day, a half an hour, and sometimes those conversations can get you into a grad school, or get you an internship, or get you into TAing a class, or just maybe make you friends with this cool professor. So yeah, be respectful of their priorities, and also put in the effort to learn what they're trying to learn, is what I would say.
I completely agree with everything that you said. I think, like, in some instances, I've seen students that are like, oh my god, like, I really want to work under this professor. Like, they aren't responding to my email. What do I do? Like, help. And I think, like, professors are, I mean, everyone is incredibly busy, but
Go in
professors
person, Ava.
especially are very busy. And I think I completely echo what you say about, like, being respectful and, like, being very, like, transparent and open as you can about, like, what exactly your interests are, how, whether there is an opportunity for you to get involved, and if not, still, you know, there are so many other ways to get involved with a professor that is beyond, you know, working on research. It could be a TA thing, it could be, like, you know, you can just, you know, meet with them and pick their brain. I think it's really important to form, like, communities of mentorship, because at the end of the day, like, it's going through, like, school alone is really tough, but, you know, the professors have gone through it, and, you know, if you're interested in doing research, like, they have gone through that as well, and so they are the ones that know the most about, like, what is the research culture like, what are the biggest questions in your field, and even having a conversation with them about that is really, really interesting.
And I had something to say, and it completely disappeared. It's fine. It's fine. Whatever it was, clearly wasn't that important. All right. But yeah, I'm totally with you on that. What are the big questions in the field? Because they're going to be aware of current papers, of current research, of current things. Because oftentimes when you're doing research, you're reading up on the other things that are happening because you want to make sure that someone didn't do your thing already. So, like, yeah.
I think, like, also, if you are working on a project with a professor, like, that doesn't mean you should shut off the possibility of forming connections with other professors. Like, I feel like there have been so many instances where I've, like, you know, been working on a paper and been, like, you know, sent it to another professor who's, like, working tangentially in the field. And, like, of course they're busy, but, you know, just showing, like, what I'm working on and, like, the main conclusions being like, hey, like, I would really love your insights on this. I think you have another perspective that I want to make sure that I'm addressing in this paper or in this project. And I think even that is, like, a really great way to form a connection, and also to, like, you know, just chat about, like, what they're working on and what questions they're interested in answering.
Yeah, it's like what I had said with the that one professor who would point us to other people who are like, this person's an expert in the field. I can give you my 2 cents. Please go get their 2 cents as well. Like, that's such an important thing. And then what was it? Oh yeah, yeah. When working on research, again, I've totally had that experience as well, where it's like, this person is knowledgeable about what we're working on. Shoot them an email. Just say, hey, this is what we have. What's your take? Like,
yeah, I completely agree with everything that's being said. I think, like, to go back to, like, the main question of, like, how, I guess more so, like, how do you form connections? Because I think a lot of the stuff that we've been talking about has been, like, you know, if you already have a research group or if you're looking for a collaborator. I think one of the things that you mentioned at the start of your answer was, like, going to office hours, and I really, really want to echo that, because I know so many people in physics who met their research PI through office hours, or their first research PIs, I guess, to be more specific. I think another thing is, like, cold emailing is also great, but I think really is a value in, like, meeting a professor in person.
Oh yeah,
and also, like, looking at possible, like, summer research programs. There could be an opportunity where a professor has, like, a listing out for, like, an undergrad position in their group, or seeing, like, what kinds of questions you're interested in.
Totally. It's and there is a level of difficulty, because unfortunately, as is the case in many things, there is a little bit of it's who you know.
Yeah.
Like, if, of course, reach out to who you can reach out to and talk with who you talk to. Is the professor at the community college maybe gonna necessarily gonna have a connection with someone at MIT who you're really interested in. Maybe not. but it's
but I
still
think
worth
like
reaching
what's
out.
really interesting is that like a lot of people meet their like PIs not from like the first person that they meet, but from like the second or third. And like it's exactly how you were saying about like how you might meet with the professor and being like and say, "Oh, I'm interested in so and so," and like these are the kinds of questions that like tickle my brain. And they could be like, "Oh, wait, I know this person who may be more down your, you know, might be answering those questions more directly."
So I guess it's not necessarily who you know, it's who they know.
Yeah, exactly. I guess actually this might be an interesting segue into the question we had about job opportunities. I think like one interesting thing that I did want to point out is like I feel like I don't know about your experiences, but there are also job opportunities that you can find through professors as well. Or that they may know a former student of theirs who went from academia to, or I guess vice versa. And so I guess that's kind of related to our previous question. I don't know if you wanted to add more to that.
Funny enough, it is kind of just it's very similar answer of meeting with people and just asking them the questions that you have is so important. And yeah, I don't really know what to say more beyond that of sometimes that conversation is really all it takes. That conversation can spurn so much potential, or can create so much potential, so many potential opportunities for new avenues, for success, for opportunities. So again, the whole theme of this is reach out to everyone. You know, it's never too late to stop learning. Everybody knows something. Please talk with people.
Amen to that. Yeah, no, exactly.
The academic equivalent of please touch grass is please, talk with your professor.
No, for real. Yeah.
Oh.
Well, I'm taking a look at the document. Were there other specific questions? Oh, we should also answer the questions from chat. Do you want to do a rapid fire of 3 quick questions?
Let's do that.
And then we can maybe find one question to ponder on.
Yeah, shoot.
So the first question is by bystander0422. What are your guys' favorite kinds of numbers? What number is your favorite and why? I think you need to answer this question first, given you're in the math one here.
So, funny enough, so numbers I do not like. So I end up this is how I do it. Numbers I am not a huge fan of. I would say do not like, but I will not preference. I don't really care for square numbers because they're too pretty. I don't care for most even numbers because, again, too pretty. Some even numbers are fine.
All the numbers.
For example, 52. 52 is a great number because it feels like it shouldn't divide by anything, yet it divides by 4, and then you end up with 13 times 4, which is weird. I like that.
Yeah.
Because it's just offset enough. 54 is one we know, like 9 times 6. Yeah, that's easy. But 52, there's no way that that's divisible by anything beyond 2. Joke's on you. So I like that. Of course, you got to give your shout outs to E and to Pi, because E shows up all the everywhere in nature.
Oh, for Pi.
And pie is tasty. It's a baked good. That was a big part of this earlier. And oh wait, let me find. Oh god, I don't remember what the exact one is. There is a sequence of, I forget what these are called. So there's so imagine you have the sequence of prime numbers. There is a sequence of, I want to say, 21 consecutive prime numbers that when added together... Wait, no, I need to fact check this.
What?
Will... here, you do yours and then I'll come back. I need to grab the exact number.
Well, I don't think I have a favorite number, but like I really like pi. So Eggy says mandatory 6-7. I don't like 6-7
I
because
was
it
waiting for
confuses
that.
me. No, literally, it's so I like when people do the 6-7 motion for like two numbers that aren't even relevant. Like somebody was like, "Oh, 6-7, what's that mean? Like, do you just do like 3-4 or something?"
I think you should start doing it and be like 1, 2, 3, 4.
1, 2, 1, 2. Anyways, yeah. I really like the number 40. I actually am a very superstitious person, and my lucky numbers are 7 and 40. And so sometimes, like when I'm really like nervous about something, I turn it in at like 7:40 p.m. Like I literally wait until like that specific time to turn it in,
That's awesome.
and it's worked. So I guess it's good. It's good.
That's awesome.
Yeah.
Wait, I'm sorry. I'm trying to find it because I can't remember what it's called. I like made a short about it once, so I'm like scrolling through my YouTube shorts to like try and find it.
That's so fair. That's so fair.
That's what it is. Oh, here it is. Consecutive prime sums. So
Consecutive prime sums. Interesting.
So it's if you, like I was saying, you sum a series of consecutive prime numbers, and I believe it's the sum of those is also prime. So
that's really cool.
That's what it is. There is a series of 543 consecutive prime numbers that add up to 997,651, which is also prime.
Okay. Wait, that's so interesting. I did not know that. That's really cool. That's a really fun fact in math. Right. Yeah.
And that's the largest consecutive prime sum underneath 1 million.
Wait, there's no way. That's super cool.
Yeah, no. There's that sort of things where there's like full of those weird patterns. There's like, oh my god, I have so many of these like pan-digital numbers and stuff where you end up if you take like a pan-digital product is if you multiply two different numbers together, both the multiplier and the multiplicand and the product all only contain 1 through 9 once, like in total.
What?
So like here, let me find an example.
Like 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah, like throughout all three numbers, each of those only shows up once.
Oh, that's what? Wait, that's so weird. That is so weird. Wait, what is this called?
A pan-digital product.
Pan-digital products. I looked it up and all I'm getting are ads for like camera.
Too.
For photos or something.
God. Okay, pan-digital.
ProjectEuler.net. How do you pronounce that? Now that I think about it.
Euler?
Is it Euler? Okay,
yeah,
I was gonna say.
Yeah, don't.
The Orbeez have been like getting on my pronunciation recently, so now I need to like check everything.
No, yeah. Euler. Let me find it. I for some reason I can't find the, like, so if you look at pan-digital numbers, you can find it, but I'm like.
Mertens' third theorem. Wait, you Orbeez are teaching me so much about math.
Yay!
Wait, this is crazy. Wow. Didn't know that Euler's constant. I feel like I've seen this before, but there's like a Wikipedia page on it. It's really interesting.
Oh, here we go. So like, we have something called the polyvisible pan-digital number, which is the only pan-digital number where the first n digits are divisible by n. That number is 3. Here, yes. What is this? 38165479290, and it's divisible by, I guess, 10 or 9. Wait.
Okay, so it has every number digit once.
Right, and then
the only 10 digits. The first n digits are divisible by n. That is so cool. Let me just put the Wikipedia article into the chat you Orbeez can check that out. That's super cool.
Nerd out with us.
Yeah. This is great.
Yeah, there are a ton of fun numbers beyond, like, people, I have a feeling when they ask that question, they're gonna be like, okay, what's your favorite integer or complex number
Yeah.
or something? I'm like, okay, what about these weird ones?
Yeah, no, this is really weird. Huh.
This is all in the realm of pure mathematicians, so, like, you know, this is applicable nowhere, but it's a really fun fact. Oh, that
Wow. No, these are super cool. Wait, this was such a creative answer to this question.
I actually have a relevant joke for this that my coworker told me the other day.
What?
Just,
What is it?
Just about pure mathematicians.
Oh.
So, two people are hiking in the Grand Canyon, and they are lost. They don't know where they are, but they're like, we started hiking, we're completely lost, we don't know how to get out of this. And they look up above them, and they see a person in a hot air balloon. Miraculously, the person in the hot air balloon notices them, and they call up. They're like, "Hey, you can see all around. Where are we? Can you point us in the right direction?" The person in the hot air balloon looks down and goes, "Looks like you're right there." And one of them goes, he's a mathematician. He gave me the correct answer, and it was completely useless." That's pure math in a nutshell.
Oh my god. Wait, do you do, like, I guess, like, when you're doing pure math, I feel like also the way you communicate is through proofs.
Mm-hmm.
Right?
Yeah.
I feel like when the first time I learned how to write proofs, it was really hard. But then, like, once you kind of learn the language of proofwriting, it kind of makes sense.
Yeah.
I guess I was curious, like, when you're dealing mostly with proofs, like, how do you, like, do you ever present your results to, like, the general public? Like, you know, and, like, how do you, like, translate that from, like, proof language to, like, more accessible language?
So that's the great part about being both the great and the tricky part about being in applied math. So I have to make all of my points, or I have to discern all of these things through the axioms, through the theorems, through the proofs to find my answer. Then I have to translate it into a graph or like a scatter plot. Then I show it to researchers, and the researchers go, "That's crazy." That's impressive. Yeah. It's pretty much that, where it's like when you're intermingling with other mathematicians, proof it up, you know. That's where you're working in theorems. But the second you have to present it, not only to the general public, the second you have to present it to somebody who's outside of the field at all, the second I have to present it to a biologist or a physicist or anything, I have to translate it into even if it's still in, like, mathematical terms, it has to be something that's understandable by tons of different STEM fields.
I see. Yeah, I mean, I feel like translating that it can be pretty tough. Yeah.
I think it depends on I think it comes down to what you said previously with the skill of language of proofwriting. Because if you understand, like, the definition of an even number is, you know, 2 times n, where n is an integer kind of thing. But if I then just say that to a regular person, I just go, "Oh, a number divisible by 2, and people will know what I'm talking about.
Yeah.
So it's just that when you're setting up those proofs, taking it from what am I thinking about up here, where I'm thinking of even numbers. When I write it down, I have to write it in the weird way. When I say it, I can say it in the not weird way.
Yeah.
I think that's my best way of putting it.
Wait, I love this take. Yeah, no, I was really curious to hear, like, what you thought about this, given that, like, for me, like, astrophysics, I mean, it can get pretty technical, but at the end of the day, like, space is something that people can visualize, and people generally know, like, what the Milky Way is, or, like, what a galaxy is.
Candy bar.
And I guess I was wondering, like, when you're going, I know you do, like, more applied stuff, but, like, even when you're going from math, which I read this statistic the other day that, like, a majority of the people in the United States, like, have not taken anything past calculus. And, like, when you're trying to deliver your results to an audience that may be afraid of math or, you know, very unfamiliar with it, like, trying to think about, like, how do you communicate that?
It's It's tough. I actually, funny enough, on Monday, I even did a stream specifically on math anxiety, because it's a huge problem of people who are, like you said, scared of math, and haven't taken stuff. Unfortunately, like with any field, there is this, like, it's tough. There's a level of jargon you have to know for any field. I can't necessarily understand the in-depths of quantum mechanics without knowing some jargon. People can give me a good metaphor for it, but that's as far as I'm gonna get. So you kind of have to go in with the assumption that they know something.
Yeah. Well, I think, like, also one of the biggest mistakes that I see in science fiction, especially, is that some people start their presentation out really basic. And, I mean, like, yes, there may be some instances where the audience has never thought about galaxy science before, but I think, like, in a lot of instances, people can put things together pretty quickly. And so, like, being able to balance that is really important, and I think that just comes with, like, getting feedback from people and, you know, presenting a lot of times and practicing.
It's the one of the a good guideline I got on it is, like, so, you know, your abstract is where you present kind of the gist of it, the basic or the main takeaway, so someone can read your abstract and understand, while still having some knowledge. And then the place that you can really nerd out is in, like, your methods section, because I can get the intricacies of your results from your results section and from your abstract and whatnot, and I can get the general idea from your introduction and stuff and the problem. But if you want to explain in depth what you did mathematically or scientifically, go crazy in the methods section. And if someone doesn't understand it, they won't read it, and that's fine.
Yeah.
Matt, thank you for the sub.
Yeah. Well, I've also been reading through chat about all these really great ways of, you know, well, some people have been suggesting their favorite numbers, but also just thinking about, like, some people haven't really been reading recently. I think now more than ever, it's important to be communicating science and, you know, being able to share knowledge and truth. Especially in this era where we're getting a lot of misinformation.
For sure.
So, yeah. Well, I know we're coming up on time, but I was wondering, did you want to end up on this last question here? I think just some general advice. We got a question that was, my brother's studying physics, do you have any advice for him other than thoughts and prayers? But I think we can just end the stream by saying, like, do you have any general advice for pursuing math? And then I can answer for astrophysics. Does that sound good?
Yeah, I like that.
Yeah.
I think the key is, first off, understanding. Don't do what I did. Don't just go through the motions. Don't become a mathematician. No. Taking it slow. Taking it slow, understanding what every aspect is, because you're learning what a derivative is for a reason. People care what a derivative is for a reason. It's important to have that context, and if you don't understand it, as one of my favorite professors once said, convince yourself that it is true. Mull over it, look through it, look at the surrounding pieces to it, and really try to understand what is a derivative, and why does this definition for a derivative work? Why can I make this conclusion? It's gonna go really far, because when you learn that in calculus, what a derivative is, when you apply it to 10,000 dimensional vectors, it's gonna make sense.
Yeah. Well, no, that's a great answer. I think for me, like, well, first, I echo the two things that you said, because those are already things that I was thinking about. The first being, like, be sure to take it slow. But I think also the second part is, like, learning is not just memorizing equations or just, like, being able to pencil stuff in or plug and chug, but it's also about building intuition. And I think at the end of the day, having the intuition to solve different problems or to think about, you know, like, what the applications are is pretty important. And it's not just, you know, completing homework after homework, but also being able to mold your brain to think a certain way. I really, really love the term to like think like a physicist, or I guess maybe you're think like a mathematician, because that implies that you're not just, you know, like finishing your homework or like plugging and chugging numbers, but also just like fully changing your like neuron chemistry to be able to think in a whole new light. And I think like, I guess 2 additional pieces of like I have, and especially for physics, is I guess also applicable for other things. The first is ask questions. We've talked a lot about like building intuition and like, you know, taking it slowly. And I think a really big step for that is to be able to ask questions. And most of the time people have the same question in their mind, or you may expose like a really big gap in your understanding that you didn't know that was there before. That will build your intuition. And the second part, which we've talked about a lot during the stream, is also finding mentors. It's really, really hard to do math. It's really, really hard to do physics. It's not an easy path for anyone. And so being able to find that kind of mentorship, whether that's in other students, whether that's in a professor, whether that's in TAs or other older students, that will help you so, so much in being able to find out what your path is. Or even if or like what other career paths you could consider. So, yeah, those are just my 2 cents. And if any of you guys in chat have anything to add on, like, please, this is open space for conversation. Or if you want to add anything else.
No, I that honestly covered it. The word I was looking for, or like I love the word intuition. That's perfect. That's such a perfect example, because you do need to mold your brain to be able to think in those different ways. That's so important to change the way you think, so that you can start identifying and seeing patterns, because that's going to be huge.
Yeah, and I think another thing is like, it's pretty hard to do that. Like, it's hard to rewire your brain or to mold in a specific way. I think nowadays with the unfortunate truth is that, like, with AI and with technology, I've been reading this book called Stolen Focus, and it's been describing about how people don't really like to learn anymore because they find it hard. And learning is supposed to be hard. With like apps like Duolingo, it may seem really easy to like learn a language, for instance, but a lot of big part about learning a language is practicing and making mistakes and, you know, struggling through concepts and then learning and growing through that way. And the only way that your brain can grow is through struggling a little bit. And so I think, you know, learning is a tough journey, which is why mentorship is so important. And I think you shouldn't feel upset that you're maybe going through a hard time learning a concept, but rather sort of reframe it to say, oh, I'm growing my intuition about this topic, or I'm really curious about this, and yeah, this is really, really hard, but at the end of the day, like, I will learn something really cool. Yeah.
I don't think I can top that. That's yeah.
No, I've been reading up a lot on how education and like focus has changed with technology, and I think now more than ever it's really important to, you know, share the stuff that you were talking about, like taking it slow and, you know, learning just beyond the problem sets as well.
Yeah, absolutely.
Yeah.
Well,
I think we're coming up on time.
Yeah.
Anything else you want to add, or any last announcements or anything?
I don't think I have anything. No, yeah, I feel like we got through everything pretty well. Thank you, of course, for making this all happen.
Yeah, no, I mean, no, thank you for also suggesting these questions, and I'm really glad that we were able to chat about this.
Me too. I not enough people are. I feel like there's a lot of pressure to, for example, go to college, get a higher education, that sort of stuff, but not enough people are willing to be like, okay, what about these seemingly very basic questions about it? No one has those answers, or if they do, you know, it's sometimes of, oh, you know, it's an experience, you'll find it out as you go, instead of someone being like, how do I do this?
Yeah, no, exactly. Well, I I just wanted to close off by thanking you again. If you guys haven't already, go to the pinned comment on YouTube to go check out Poi's channel, Poi's on YouTube. Super cool content. I guess for any announcements on my end, I actually think I'm going to maybe spend I might stream maybe next weekend. I'm really sorry for not streaming as consistently, but I think I really need my voice to recover. I have some pretty big presentations that are coming up, and I would really want to rest my voice and make sure that I'm in tip-top shape for that. So thank you all so much for your patience as I've been going through this like health crisis. But alas, I hope you enjoyed this stream. I hope you really enjoyed. And then for those of you guys on YouTube, we should see you to raid. I was planning to raid Nerduino, who is a PhD astronomer. I also know that Gaussian is streaming, so I'm actually gonna shout out Gaussian. So go follow Gaussian, and then we're gonna raid Nerduino.
Cool.
So let me if you're on the Twitch side, let me just copy and paste the message. And yes. Alright, I think that's all set and ready to go. So thank you all so much for joining. Thank you, Poi, again, and we will be ready to raid. Alright.
Thank you. Thank you, everyone.
Bye-bye. I will see you guys in the next one.
Oh, that's clever.
Bye-bye.
Bye-bye.